Hey guys, and welcome back to my channel. And today's video I'm going to be discussing how to install a tri-fuel conversion kit to your portable generator. This is a customer's machine. It is a Black Max 7,000 watt running with a 13 horsepower Honda engine, and we are going to be installing the US carburation Motor Snorkel kit on this machine. So I did do the full service and maintenance on this machine, so it's running good on gasoline off camera. And I'll discuss a little bit of that after. We are going to load test this on gasoline to the full 7,000 watts to make sure everything is running properly. I did do some adjustments to the speed and the voltage, so that was needed to be addressed off camera. But the install process for the Motor Snorkel is pretty straightforward. However, I don't see a lot of videos doing more detail on how to adjust the demand regulator, the load block that is on top of it. We're going to go and do some assembly upstairs in the office first to get these parts prepared for installation into this machine, and then I'll discuss some of the important points on what you need to look out for when you are installing a kit like this, because if it is not adjusted properly, that can cause serious damage to your machine that you do not want. Here we are up in the office. We're going to do a little bit of assembly first before we go back down to the generator and install these components. And I wanted to go over what components you're going to be getting, what they're used for, and some of the notes to make sure you don't fall into any pitfalls that you may encounter when installing a kit like this. I am happy to report that they send this is actually the first kit that I bought in a very long time from them. I converted two of my generators years ago. Hurricane Sandy, Hurricane Irene. So we're talking 2011. That was the last time I bought a kit from them. But I'm very much familiar with the company. They've sent these instructions have actually evolved to be very colorful, very illustrated. If you really have any doubts or questions, this is actually going to be very helpful for you if you've never done a conversion like this before. There's two pieces that you're going to need to order from motorsnorkel.com. It's important that you get the exact model number of your generator, the brand, and then also the model of your engine. If you do not see it in their selector program there, you can select the down menus for your brand, for your model, and all that stuff. If you don't see it in there, give them a call and they will be able to help you. They don't always have every single model number available on their website, and it's kind of impossible to do so, but just to make sure you get the right one. James Condon, I know you must be watching this video, so shout out to you. You did a conversion on this a while back, and you ran into where the snorkel here, this is part of the tri-fuel kit, where the snorkel hose comes off of this side, but say I think you needed to have it come off on the other side instead because of the way the engine was oriented. That's really the main goal, to get the right model number for your engine and for your generator. Otherwise, if you get the wrong snorkel, it's not going to fit properly and you can't exactly put it upside down like that. They just want to make sure that they give you the right one so that the hose clears, it's not going to get kinked or anything like that. So that's really the main goal, to choose the right kit. Now, the rest of the kit is going to have pretty much the same parts. You're going to have this large demand regulator. You're going to have they're going to give you these mounting bolts for it, some zip ties, washers, all that good stuff. On the instruction booklet, they even give you a template to where you can actually go and drill the holes out on the side of your frame. So that's going to come in handy. I didn't have that years ago. That's great. And they also will send you the load. This is what's called the load block, and I'm going to be spending a lot of time talking about this because you can do all the installation pieces correct for a kit like this, but if this load block is not set properly, you can cause some serious damage to the engine on your generator. And I'll talk a little bit about that first before we go into the next of the building process, because if you're not careful, this could really become a problem for you down the road, even after you have this installed. So the kit's going to give you everything that you need to go and put the demand regulator and the load block together. They're going to give you a package of pipe dope that you wipe on the threads, and that'll cause it to have a nice seal. They'll give you all the mounting hardware and the zip ties, as I mentioned before. Now, this load block is going to be a very important step when you get all these components on the generator.
It's the opposite of what a lot of people are understanding of gasoline engines. So if this is going to regulate the air and fuel mixture, it's going to restrict the gas flow, thus the air and fuel mixture going to your engine. Gasoline engines, if they are running lean, meaning that there's not enough fuel going from the carburetor into the engine, you're actually going to make that engine run very hot. You're going to get higher exhaust temperatures, and that's not good either. If you are running rich, meaning putting more fuel into that engine than it can burn when it's in the combustion chamber, well, then it's actually going to run much cooler, but it's running very inefficiently because there's gas that's not being burned in the combustion chamber. It's going out the exhaust, and then you're going to see your exhaust burning a lot of black smoke. You'll see it black on the spark arrestor, and you'll get extra built-up carbon in the engine. It's not very good, but it's running cooler. It's the opposite when it comes to gaseous fuels like propane and natural gas. So the leaner on propane or natural gas that your engine is running, the better. The richer, you're actually going to be running it too hot, and that is where you can get into big trouble with these conversion kits. A lot of the reviews that I've seen on whether you get it from Motor Snorkel, there's a couple other ones that you can get that they may not have the snorkel, they may have the Venturi, this donut-shaped thing that goes in between the airbox and the carburetor, and the same problems. If they don't adjust this load block properly, you run that engine too rich on it, and your engine starts to lose power, or it just doesn't start at all. It's because it was running too hot. So what we're going to have to do, the way I do the load block adjustment, is I have a load bank that I can load the generator up to its full load, full rated load, continuous watts. And I'll first start adjusting this load block as lean as possible without a load. And then as I add 1,000 watts, 2,000 watts, it's going to start to want to lean out. So I have to counterclockwise bring this out to make sure that the engine has got enough fuel to support that load. And I'll keep doing that back and forth with my load bank until I get to the full rated 7,000 watt load. And that's when I'll lock this down, because now I know that the air and fuel mixture is set properly to be able to support a full load.
So the Tri-Fuel Kit on its own is going to come with these parts. You're going to have the demand regulator. You're going to have a 3/4 inch male national pipe thread to 3/8 inch flare adapter, and that's going to go to your inlet port right here. All right. Then you're going to have your load block, which already pretty much comes pre-assembled. We're going to have to put some Teflon tape to seal all these threads, and that's going to go on top here. That's everything that's going to come with the Tri-Fuel Kit, and then obviously you got the snorkel, which will connect to this barb here. Here is the NPSK kit. It comes with this hose, it comes with this tank adapter, your primary regulator, this 3/8 national pipe thread male to 3/8 inch flare male, and a little bit of Teflon tape. And we're not going to look at these right now. This is actually a quick disconnect, but I don't have enough parts to install this properly, and I'll talk about that later. The only thing that this customer wants different than this tank adapter that would normally go right here, he doesn't want to have this be on here because he doesn't want to have to use a wrench to connect this hose to a tank, especially if it's dark out and you can't really see what you're doing. So he elected to take this out of play, and instead he's going to want to have this POL thumb nut installed, which is the same type of connection, but instead it uses this thumb finger style type of adapter where you can put this on with your fingers and not have to worry about using a wrench. So this is actually what I have on my setup, and that's what he wanted to have put in differently. That doesn't come with the NPSK kit, so this would have to be purchased separately. So when you buy the NPSK kit and also the Tri-Fuel Kit, you'll get the snorkel and you'll get everything that's pictured here. The only thing that he's modifying is this POL thumb nut, and this is how it would connect to the demand regulator, and it's pretty much a plug and play. But because he wants to do this quick disconnect fitting, I'm going to run into a bit of a slight issue where you're going to need different parts in order for this to work. So this has male pipe threads. I need to have a male pipe thread to 3/8 inch flare to connect this piece over to the tank, or to the, I'm sorry, not the tank, but the hose here. And then in order to get this quick disconnect to go to this demand regulator, I can't use a flare fitting. I need to get a reducer from a 3/4 to a 3/8 female, and then I can use this male to male adapter that it came with in order to connect this like so, and now I have my quick disconnect. So I did order those parts. They should be here in the next day or so, but that's the only two modifications. So the quick disconnect here and the POL nut is the only difference here. Everything else should be plug and play. So until I get those parts, I'm going to set it up like I normally would from the kit. And obviously we're just going to put this in since I already have it. So when I do eventually get all the parts, here's another kit that I did. You can see where I have the male to male piece right here. I have the reducer from 3/4 to 3/8 female, and this is comes with the little dust cap here, and then that's how I connect the quick disconnect here. So this is what we're basically going to do once I get all the right parts. But and then here's also the load block, and you can see that this is a Garrettson, and the one that they give you is a Sentry. Really no big difference. They're all set up the same way. So let's go ahead and start putting the pipe thread tape on everything, and we'll hook it up like this for right now for testing purposes, unless I get these parts earlier than I expect, and then we'll make sure that that quick disconnect is on there. $18mm. Okay, so this is pretty much ready to go, and I have this current adapter in now so I can just connect the NPSK up for testing purposes. But my thought is that I'm probably going to get the parts I need for the quick disconnect before I get this all mounted to the generator. But for those that are watching that don't elect to have that quick disconnect, this is what it should look like. And we're also going to have to test, once it's on the generator and it's filled with gas, it's pressurized, we're going to spray some soapy water at all these locations to make sure that there's no leaks. And another note to make sure, you do not need Teflon tape on these threads here. There's no need to put Teflon tape here, and that's actually been, it's actually in the manual somewhere, but you do not need Teflon tape here when you are putting this load block on. This should remain bare thread. Quick aside here, guys. So I did get the updated parts here. So I'm going to replace what this came in the kit, the 3/4 MPT male to 3/8 flare male. And we are going to replace that with a reducer from a 3/4 to a 3/8. That's going to go here. Then we're going to take what we got in the quick disconnect kit. So you have this side, which is going to go onto the hose here. And then we have the quick disconnect, which has to go here. And in order to do that, we're going to use the male-to-male hex nipple that they gave us, 3/8. That'll go here. And then this quick disconnect is going to go right there, and I'll get the dust cap to put it on. This one, we're also going to need to get the additional 3/8 NPT male to 3/8 flare. That will go here and go onto the hose like this. And the thing that is important to note is that the flare fittings do not need Teflon tape to be sealed properly. Once the assembly is complete, this is what it's going to look like. We'll have the POL nut, 3/8 to 3/8 flare, connected to the 12-foot MPSK hose. Then you'll have 3/8 flare to 3/8 MPT male to the quick disconnect. And then over here, 3/4 MPT male to 3/8 female reducer. We have a hex nipple, 3/8 to 3/8 MPT, and then the quick disconnect has a 3/8 female. I put the dust cap on, and everything is all set. And this is all set up already coming from the kit. All right, guys, we are outside. We're going to be testing the generator today. Now, what I did do is get everything put together. It's currently gassed up, and just taken some soapy water and sprayed it at all these locations to make sure that there's no leaks. We have not connected the snorkel yet, because what we're going to do next is we're going to load test it just on gasoline. I got a full 7,000 watts of resistive load in order to
load this up all the way. And I want to make sure that it can handle a load on gasoline, no problem, before I start making the conversion. I have already mounted this to the generator. It's very easy to use with the template. You just get a 1/4-inch drill bit and drill through using the template. And be strategic on where you put this, because you don't want it to be in the way where you can't get to the spark plugs or anything like that. There's a primer bulb behind here, which I'll show, that you need to be able to access when you're starting it up on propane. But it looks like we're going to be in good shape. This is a good position for it. The snorkel is going to come out here and then go in between the air box and the carburetor. Right now I'm not seeing any leaks or anything like that, so this NPSK kit with the thumb nut modification is good to go. Plus we have our quick disconnect here, which we can do just like this. Makes it very easy, and I'm really liking the progress. So let's get you set up a little better for testing on gasoline first.
Here's the test setup we're going to do for gasoline first. We have a 5,000 watt resistive heater, and we have two 1,500 watt heaters, each balanced on the windings of the power head. And what we're going to be doing first, get this closer to me so I can turn it on and off. This is selectable to 3, to 4, and 5,000. We're going to start with 3 first to make sure everything's good. And then what we have here is the kilowatt meter, so I can monitor the speed. What's going to be important is that the engine be tuned properly on gasoline first. I should see about 62.5 hertz, no load, about 125 volts. And then at full load, should see no more than a drop down to 58 hertz. And the voltage should go down a little bit, but not too much where I would think there might be a problem inside the panel here, indicating a loose connection. But we're going to start up on gasoline and go from there. Well, that was not fun. Looks like I got to fix that next. Well, that was a little bit annoying. Thankfully, it's just a little replacement of some rope, and we are back in business. I didn't bother filming it because you've seen plenty of videos on this. Let's get this back on the generator so we can go and test it out on gasoline. Let's try this again. Supposed to start. Unfortunately, this doesn't have an electric start. Alright. Well, it's not leaking gas. A little bit of starting fluid. Well, that wasn't a very good test. I shut off the gasoline petcock valve for the moment, but I think I see the problem. Now, I cleaned out the carburetor bowl, and I was able to get this running, but I haven't taken the carburetor completely off yet. And if you can see the linkage right there, this is for the choke right there. It's actually not moving the choke at all, which would explain why it was so hard to start and it only started on starting fluid. So it looks like we need to fix that linkage, and I think this machine was starving, gasping for air because it was running with the choke almost completely closed. Let's see if we can get that fixed, and we'll try again. Well, that looks to be the problem here, because this is where it was vibrating. It was actually keeping the choke closed. This little arm is supposed to be in there to hold it open. And I guess that would also explain too why it smokes so much when we shut it off, because the choke probably closed from the vacuum and drawing all that raw excess gas. So let's get this piece back together. I'm going to put the airbox back together without the snorkel, make sure that this is going to run good on gasoline before we do any other modification, and test again. Okay, so now that we got this all put back together, you can see where it's now engaging the choke damper there. And when you pull this back for choke, it should close it all the way. Now, it doesn't open it up all the way because we have a vacuum solenoid here, and as long as the engine's running, the vacuum should open it up all the way, like that. But right now, it's just kind of holding it at half choke. Should be a lot easier to start this time. Put everything back together, stock, without the Tri-Fuel Kit, and let's try that. May have to adjust the speed again. Double check that. Gas is on. Do full choke, and this should fire right up, hopefully. Well, this is getting interesting. The motor cannot keep up with a 5,000 watt load before it starts to stumble and lose speed. And it is definitely not a dirty carburetor, because it would have been hunting and surge in here. The only other thing I can try is adjusting the governor spring here. You can actually go to a different hole on the governor arm. I'm going to try to move it onto that inside hole and then reset the speed and see how well it does there, because when I hold the governor arm under load, it can actually handle it. So I'm thinking it might be a governor setting issue. So Let's give that a try. Well, I tried doing a governor adjustment and moving that spring to the inner hole, but that did not work because what wound up happening is that I ran out of travel in this screw for the high idle speed, and that wasn't going to work at all. I did move this plate up a little bit so that it's straight on because this screw was actually going above it. I figured that might be the problem. Turns out it was not that either. I then did a zero governor where I loosened the pinch bolt and adjust it there to make sure that the governor has full travel. And that still did not solve my problem. The only other thing I'm going to check at this point, I have to let the engine cool off. When an engine is not able to maintain speed under load that well, and generators, it's important to have anywhere from 58 to 63 hertz, no more than that. If it can't keep within that range, the next thing I'm going to look at is the valve train. This engine has good compression, otherwise it wouldn't be running this smoothly without it. But chances are, even though it's only got 100 hours on it, the valve lash might need to be adjusted, because if the valve lash is too tight, yeah, it will run, but it won't get full power. And you have to adjust the valve lash when it's cold, so I'm going to let this cool off and we'll come back to it. My amazing wife made me a coffee as we're waiting for the engine to cool off, and we're going to go take a look at the valves. The intake valve got the right amount of lash. Pull this past. The intake's open. Not seeing any. This looks about right. Let's put some feeler gauges on it and see where it's at. Well, it looks like my hunch may be right. These valves were extremely tight, more so than what the spec calls for. The intake is supposed to be 0.06 of an inch clearance, and with a tolerance of 0.001 thousandths of an inch, and the exhaust is supposed to be 0.08 thousandths of an inch plus or minus 1 thousandth of an inch. So I found that the exhaust was somewhere around 4 thousandths of an inch. And normally that's good for most motors, but hey, gotta go by the spec. Let's go and put this back together and see if it will support its full load now. All right, let's give this a try. Well, unfortunately, that was a dead end. It did need to be adjusted, which is good. That's at least one less thing to rule out. But I think I'm going to need to go and pull the carburetor here, and I'm going to need to do a leak down test now and see, are we losing compression? Because it seems that this engine does not have enough power to maintain the speed. Quick compression test shows that we're about 80 psi, and that's with the compression release. So we are definitely getting some good compression here. I don't think we have any valve train issues, so I'm going to move on to the carburetor. I was going to go and do a cylinder leak down test, but seeing these numbers, I think it's safe to say that we don't have any engine mechanical problems here. We're going to have to look at that carburetor. Well, here we are on the bench, and the inside of the carburetor was a little dirty, but not bad. Took out all the jets. It's basically just a plug here. I did clean this out. I do have some micro drills, and I kept it the same size. Blasted some carb cleaner through it, and blasted it out again with the air compressor. And everything seems to be cleared. Now, the only thing I didn't take off was this, but I do see the carb spray coming through these little tiny jets here, if you can see them. So I think we're good. I don't think I need to do an ultrasonic cleaning on this, but if I have to, I have to. I'm still suspect that this may not be the problem, but I had to take it apart anyway, so onward to the next step. Alright, I got everything back installed, and I got 6,000 watts, 3,000 watts here, 3,000 watts here. That's 6,000. And here we're at 59. And good on the voltage, half winding. I'm going to bring this all the way up to 7,000. Bring this to 4,000, 4 and 3, there's your 7. Nope. I can't do 7,000. It's able to handle 6,000. Definitely was a carburetor problem. As soon as I hit the 4,000, nope. So this is a 6,000 watt generator for sure. Well, that's definitely running a lot better. But the max here is 6,000 watts. I'll let it run like this for a little bit, and we should be good.
Quick aside, looks like we're getting 6,000 watts out. That's actually what I would expect after researching it for this generator. So the nameplate is basically a bold-faced lie. It's not going to be able to produce 7,000 watts, and there's good reason for it. The industry standard, when you consider the inefficiencies of a gasoline engine, it's 2 horsepower for every 1,000 watts under load in order to maintain that load. And 13 horsepower is just slightly above 6,000 watts. 6,000 watts even is likely the best case scenario in this case. If you had a slightly larger engine, say a 14 or 15 horsepower, then yeah, you would probably be able to get the full 7,000 watts, but it's slightly undersized for 7,000. Not a big deal. I did talk to the customer. He's okay with the 6,000 watts on gasoline. We're going to try to get that same amount of wattage on propane. Now, propane and natural gas, you're going to hear that, yeah, it's got less BTUs or less energy content per, say per gallon or per 100 cubic feet of natural gas. And you'd have to burn more of that fuel in order to equal the amount of power on gasoline. So are we going to get 6,000 watts on propane? Well, I think it's going to be doable, but if not, a little bit of a derate is not the end of the world. So we are going to adjust that load block correctly, and we're going to start off with 1,500 watts, move up to 3,000, move up to 4,000, go all the way up to 6,000 to make sure the engine is properly tuned. It's running as lean as possible on propane. See what we can do. But if you made it this far in the video, I really appreciate it. Thanks so much. Back to the install of the Motor Snorkel.
Here we are, it's a new day. Going to install the Motor Snorkel and then test one more time on gasoline to make sure everything is running properly. In order to install the Motor Snorkel, you need to remove the air box assembly. The air box is going to have 6 nuts here, which will take off the air box piece here where the foam piece goes. That'll take that off. And then to remove the actual box itself, the metal portion of it, there are 2 nuts here on the carburetor and then one on the back with a stud, and that's a 10 millimeter. Now the snorkel is going to go right in between the air box and the carburetor here. It acts as its own gasket, and you'll see that the probe will go into the throat of the carburetor here. Now a lot of people will ask, well, how am I going to choke the engine on gasoline? Well, the probe is meant to be crushed so that you can properly choke it. Hey guys, future me here. I want to correct an error that I was misunderstanding here. So this is what is called a velocity choke. It's basically an automatic choke with a vacuum solenoid. So the vacuum of the engine will actually open up the butterfly valve to make sure that you're not over choking it, even if you have this arm all the way out. So this is choke and that's run. And the way that this works is right now the valve is open. If I pull this closed, this is not going to close all the way in order to choke this on gasoline. And that's because of this vacuum solenoid here. There's a spring inside that allows this part of the linkage to move independently of the butterfly valve. And as a result, the only way that you can do that, and I should have actually looked at this because it's in the instruction booklet. Page 4 will allow you to fix this here, the velocity choke override. You'll have to take off that dust cap, and they actually give you in the kit for the Motor Snorkel this little self-tapping screw right here to where you drill into this dust cap and we can override that spring. So now this vacuum solenoid will no longer work as it was intended for, but when you pull this lever back and forth, it'll lock this linkage and the butterfly valve together, allowing it to close all the way so you can start it up much easier on gasoline. This is the problem we're dealing with. See how it moves independently from that butterfly valve? So I've popped off that cover. We're going to put a screw through it, and that will lock this together like that. That's what that screw is going to do. Here's how the self-tapping screw goes into the dust cap, and we'll put it back in on the carburetor, and you'll see why this is necessary for this kind of choke when you're converting to tri-fuel. Now with that screw in place, this is now locked together. We can reassemble it. You just got to make sure you push this arm forward to set it to run, just like your typical choke setup would be. Now with that modification made, watch the choke plate as I pull this arm above here all the way. Now it will pretty much completely close. It'll collapse that probe on the Motor Snorkel, and it's meant to do that. And now I can open it all the way up, and the vacuum solenoid will open this up the rest of the way, like so. I have to hold my finger there, but with the vacuum pressure, it'll hold it completely open. So that solves that problem. You need that self-tapping screw in there. We got the Motor Snorkel installed, and it's important to not over torque these nuts here. You can go ahead and torque the one back here, that's fine, but they even say here on this warning label to only torque so much, because not only is the gasket much thicker, in this case the snorkel, see how much thicker that is, you don't want to over tighten it, otherwise you're going to wind up crushing the path of the propane to go through. The connection of the Motor Snorkel coming back to the load block here is very straightforward. You just connect it to the barb, and because this is ultra low pressure, there's really no need to put a hose clamp. You could if you want, it's not a big deal, they don't give you one. I just put a zip tie here just for good measure. You should not have a problem with this flying off because of high pressure. That's what this demand regulator is going to do, is regulate that pressure to a low pressure with the volume of gas going to the generator engine that way.
All right, guys, I had a little technical difficulty.
I'll show it to you in the next segment, but right now we're on gasoline for the 5,000 watt load. 59.9 hertz. I can go a little bit more. 241 volts on both legs. So what we're going to do is we're going to shut it down. I'm going to drain the fuel in the carburetor, and then we're going to start to adjust on propane. I'll get you set up better. So off camera, I was having problems with powering this 240 volt load. All of a sudden, just everything stopped. And what I found out was that half of the outlets went out. I had this outlet, but I did not have these outlets here. And I thought that, oh, maybe a winding just went. And I had to pull the cover off here and found that all these connections were just fine. You're seeing two windings. So this is one winding, the red and the blue wire, and then the white and the black is the other winding. These are your neutrals for the common point. Everything tested out fine. It's about 6 ohms per winding. That's what I was able to get. I don't know what the exact specs are, but it turns out that the problem wasn't in the stator, thankfully. Turns out the problem was at this connector here. This wire is a Molex connector, and the Molex connector popped out of the housing. So it lost neutral at this connector right here. I got only half the windings. Thankfully, that was the only problem. But that's what happened off camera, and I was able to get that repaired. You can see a picture of it here on camera, and hopefully we won't have that issue moving forward. Now we're gonna go and hook this up on propane after I drain out the bowl of a carburetor there, and let's see if we can actually maintain a 6,000 watt load. So we're going to start with a few threads out, and then we have this primer bulb here. Give that a try. Done. We have to open it up a little bit more. Got it running on propane. I keep having to reflash the field for some reason. I'm hoping that running it on a low will reestablish that. That's where the low block is, running no load. Now what we're going to need to do, I'll set you up here. You're going to hear it stumble, and then I open up the low block a little bit more. We're going to start off at 3,000 watts. hertz. Let's get this up to 6,000 watts. All right, guys, I think that's a good setup here. Turn the gas on. The low block should be set as lean as possible to be able to support a 6,000 watt load. After consulting with James Condon, he brought up a very good point, and I did ask the customer this. I'm waiting to hear back, but this AVR part number is not the part number meant for this generator, although it is very similar. He said he has not seen a green wire and a red wire. It's usually a red and a black. Red is for positive, and usually black, or in this case green, is negative. He's questioning this AVR. If the AVR is aftermarket, it may not be able to turn on with a low voltage. It may need a higher voltage in order to turn on. Right now it's a little bit of a mystery. Wait till the next segment and we'll see what the customer has to say. Here we are a few days later. I did get a new AVR. We're going to throw this in the generator and see if that solves our self-excitation problem. If not, then the only other thing I can think of that the problem is, because I have to re-excite this generator with the drill every time, is likely because of the rotor. The rotor laminations are probably seeing a lot of corrosion. I don't know how old this generator exactly is, but what I was reading online, it seems that corrosion on the laminations and the windings could also cause it to lose retentivity, or the ability to store residual magnetism within the material of the rotor. But then again, I could be wrong. I am measuring about 4 to 5 volts of residual voltage without the AVR turning on. So let's see what happens. We'll put this in. If it self-excites by itself, then I'm going to call this project done. But let me get you set up better and we'll give this a try. Here's the new setup. We have a voltmeter so I can see if it turns on. I have removed the old regulator, put the new one on, and a little screwdriver here to adjust the voltage. We want to measure the 240, 245 volts no load. Let's give this a try. And the kill switch is on. Bad regulator. Well, All right, everything's all buttoned up. New regulators in. I'm just going to do it one more time for Murphy's Law's sake. This generator's ready to go. Well guys, I'm going to end the video here. This has certainly been a unique challenge on this particular generator installing the tri-fuel. I think I might edit this video down to a shorter version where we just talk about installing of the Motor Snorkel parts and not necessarily the maintenance on this machine. But till the next video, thanks for watching.